Clap your hands once if you can hear my voice. Clap your hands twice if you can hear my voice. Welcome back. I hope everybody had an incredible break. I'm sure you're all super well rested. And just like, I know everybody was thinking about class yesterday and going, I wish, how come MLK Day wasn't on a Thursday? But that's okay because it's on a Monday and now we're back. So let's rock and roll. Okay, I'm going to go over the warm-up a little bit later in class when we get to the third concept of the lecture. Try to keep the lecture pretty short. So I've gone ahead and added to our table that we built last class where we had our Grover's Groomers. Hopefully that's semi-familiar. We created two tables. We created users with ID, name, and age. And we created a pets table with an ID, name, species, age, and owner ID. Seem familiar? If you'll recall, this is a what type of relationship? Can somebody remind me here? What's the relationship between owners and pets? Who won? Okay, Danny.
One to many.
One to many? Okay, how do you know that?
Because there's one owner to many pets.
Yep, because there is one owner to many pets, and we can tell that from these tables because pets is holding the owner ID, therefore it belongs to the owner or a user in this case, right? So because it's the one carrying the foreign key, that's the one that belongs to the other. Just like a dog on a hike that's carrying the food in like one of those like backpack pouches on your dog belongs to you, so it has to carry some of your stuff. So just like that, our pet is going to carry our ID. Ashia.
So would it be many to many if the other table, if the users had owners?
Okay.
ID? Like when would it look like many to many?
Great. So Ashia's question is, if we wanted to make this a many to many, what would we need to change? Can anybody answer that? Isaiah?
You need a third table that references both IDs.
Okay. Absolutely. So Isaiah says we're going to need a third table that's maybe ownerships or something that would have a pets ID column as well as an owner ID column. And that would be called a joined table. Okay. I'll do a quick drawing of what something like that would look like. We'll say we had ownerships or something. This is a many to many. We would have an ID column, a owner ID, and a pets ID. Okay? So this third table would hold a reference to both of those tables, and then when we did a join, which we're going to talk about today, we would be able to see all of the relationships. Okay? And this is specifically called a joined table. Okay? That's the terminology there. Great question. Okay, so I've gone ahead, and this is I'm sticking with the one to many for now, and I've gone ahead and added some more seeds so that it's a bit more interesting, and I will slack those to you now. If you want to have your own, you're welcome to, but if you want a quick way to have numerous seeds, here you go, and these do work. I've already done it. Slacking now. Okay. This is assuming you've set yours up the same way. If not, the whole file is still available in our 6.4 Unit 3 intro to SQL tables, and then our schema.sql. So this file is available on GitHub. Not yet with the seeds, but with everything else. So today's topic is joins. Can you raise your hand if you've seen a join or used a join yet? Okay, so if that's great, I'm seeing a lot of hands. If you're not one of those, you've got to catch up with SQL Zoo and SQL Bolt. You are behind. Fear not, we're still going over it, and we're especially to reaffirm that idea. But unfortunately, this lecture will be mostly based towards the understanding that you've seen it before. But I think you'll be fine if you haven't. And if you haven't and you are confused, ask questions, right? That's totally good. Okay, so we've got our insert, and from here I've already ran the SQL file. That was with psql-f and then the relative path to the file. And I've ended up with this. Now, this still is not as ideal of an interface as I would like it to be, but it's better than what was there before. I'm using something called Table Plus, which is an alternative. If your pSQL wasn't working very well, you could use Table Plus. I'm using it because pSQL doesn't seem to let me enhance the font size at all, which would make lectures nearly impossible. Can everybody mostly see this? Can anyone not see this? Okay. I know the things on the side are harder to see. Those I haven't been able to figure out how to make larger. But we have our users table. These have the seeds. We have Korsky in there. That represents me. We have John, Jenya, Celine. You know her, and Jerry. That's my father. He made it in. And then we have our pets table. We have Nobru and Hachi. Both of those, you can see, have the owner of me because I'm the ID of one. Snowball belongs to Jenya. Coco is going to belong to my father. I skipped Gruffy. Gruffy is a dog, belongs to John. And Roscoe, whose owner is dead. Okay, or Roscoe hasn't been adopted yet. We'll go with that one. Okay, there are kids in the room, I think, today. So, maybe I'll try not to make it too dark. I don't want to make the lesson too dark, right? But it was a really long, drawn-out death. Okay. Hey, I have to keep it entertaining for myself as well. Okay. So these are our tables, and let's go ahead and make a query. And I want us to make the query, but without running it, and to decide what we think the result is going to look like. Okay, it's the game. Name the result. So let me make this a little bigger. So this let me. Okay, good. People can see that, right? Okay, so let's say I want to select from users. I'm going to select star from users. Okay, it's not going to show anything. It won't let me run something that just shows one of the plain tables. But we've already just seen this table, right? So if I want to join this users table to the pets table, can anybody tell me how I need to do that?
Join.
Okay, Danny says we have to start with join. Who can give me the next piece? Kong?
According to table name.
Table name. So we're going to say pets. Yeah, next piece. On, okay. Next piece.
We need to connect two
Okay.
keys.
So then we have to say, yeah, the two columns that we're connecting in which table. So from the pets table, I want to take the owner ID, and wherever the owner ID is equal to the user's ID. So I'll say users.id. Right? So this is a join. Another word for this join is inner join. Okay? So let me write that down. So join, and I'll put here as a reference that it exists. Inner, right? This is an inner join. Inner join and join are synonymous. That means they mean the same thing. So, like any two very closely related synonymous terms, you'll pretty much just hear join, because why would you say the whole thing when that's shorter, right? Okay, so if we had a Venn diagram, my left side here, I'm going to say represents users. And my right side here represents pets. So when we do a join, we get back this data. This is the shared data. So we're going to get it back of tables of rows, where the rows are the only, where they connect. Every single piece from these two tables has to connect and overlap in some way. Okay, so look at the data that we have, and over the next minute, just sketch out real quick or write out what you believe we will be getting back from this query. Okay? Work with the person next to you. We have about 2 minutes.
You know what? I'm not sure what exactly it's going to be. It's not like we're saying primary and name. So it's going to show everything that's in the table. Yeah. Okay, that makes sense. I think it would just show up as number. Oh, you're right. The same thing for like the building. They don't have a. Okay.
Yeah, because that'll be like
Yeah.
Okay, cool. Clap your hands once if you can hear my voice. Which pair wants to share what they think it's going to be? Hey, Calvin, you want to take a shot?
That's what we think it's gonna be.
Yeah, what's it going to be?
Joining two tables, I think we get most of the information from both tables, except for the one that's null, because the owner ID for that one doesn't exist.
Okay, so who won't we get?
Roscoe. That was Roscoe, right?
Roscoe. So no Roscoe, we're guessing.
No, Roscoe.
Anyone else we won't get? Doug? Celine. Does Celine own any pets? No, right? So, yeah, and instead of writing everybody that we think, what was it like that? Instead of writing everything from what we think is going to be, I guess we could also write what we don't think. Anybody have a differentiating opinion? Or a different opinion? It's probably a better way of saying that. All right, let's try it. So I'm going to run this current query, and we get 5 rows. Did we expect 5 rows? So maybe we did, maybe we didn't, right? So it's important to know that, right, Corey now shows up twice. Corey shows up twice because Corey has 2 pets, right? So we've got 2 different entries on the pet side that points to Corey. So Corey shows up twice. We also have Jenya and Snowball are connected. John and Gruffy, and Jerry and Coco. Coco is my parents' dog. No Celine, no Roscoe. Questions on that? Okay, so this is the join. This is the inner join or join. Let's go to the next thing that I want to talk about. Next thing we're going to talk about is the left join. Okay, so the left join synonymous term is left outer join. However, in the wild, people will be calling it left join. Okay, these are the 2 most important joins for you to know. This join and left join. You should feel totally at home and comfortable using either of those. Okay, now we will talk about a couple of other joins, but they're not nearly as important. Okay, and self-join will be something else that we will talk about, which will also be kind of important, but it's not called self-join. It's just a type of join. It will be this join. Okay, so left join. If I were to make a Venn diagram for a left join, I would have my users. My users table is on the left because I'm saying from users. I have my pets table. My pets table is on the right. Left join says I want everything from the left side. And if they have connections, even better. The more the merrier. So the left join takes all of this. Okay, so we get the middle, but we also get the users. The way this is written does not differ very much. Instead of writing join here, I'm just going to specify that it is a left join. That's the only change. Again, take a minute with your partner and decide what's going to print or what's not going to print. Okay? Tell me how many rows.
Rows.
1, 2, 6.
7. Wait, right, 6, sorry. Ross is Celine.
No, I'm not. SQ. Space. Dash.
All right, clap your hands once if you can hear my voice. clap your hands twice if you can hear my voice. What do we think? Which team wants to share what they think here? Yeah, Rafid?
So I think it's gonna have that next column with Celine and then all the information for the.
So we'll include Celine.
Yes.
Okay. So Rafid says will include Celine
As well.
as well. Like same thing as it is now, but
So
with Celine.
Yeah, and then with the when it comes to Roscoe, that'll also be there, but it's just gonna have it's just gonna be blank or say no.
So you think it will also include Roscoe?
Yes.
Okay.
But it's not. It's gonna say no instead of Roscoe.
Will include Roscoe. Okay. What do we think? What else is it? Yeah, Brutus is getting pissed off. What is it?
This is the word. It will not include Roscoe. I just disagree with that.
So Brutus says no Roscoe.
On the right side.
No
It's on
Roscoe.
the right side.
Okay.
But aside from including
Oh yeah, that is one
Yeah.
point. That is
Celine
one point.
isn't linked to a pet, so all the information following in that row will be no.
Oh yeah. that
Okay,
is
but
one
it will have Celine. Just things will be no. Okay.
point. I agree.
Interesting. Okay, so raise your hand if you're on team Celine will be there.
She better be.
Okay. Celine will not be there. Okay, yeah. Loud and proud, right? Roscoe will be there. Oh,
Okay. I did say it's gonna say no when the Roscoe. Like his name there is gonna say
Roscoe's name won't be there.
It's gonna say no, not him specifically.
Oh, that's a third option.
Okay, how about Roscoe will not be there at all? How about Roscoe will be represented as some kind of null thing? Okay, that's fine. Hey man, raise it up. Like it's okay if we get it. It doesn't matter, right? I mean, it matters, but not if you get it right or wrong right now. Okay, let's try it. Celine is added because Celine is one of our users. We have a line for every single user. We have an extra line for me because I have 2 pets, right? If somebody else had 2 pets, they'd have another line. If I had 5 pets, I would have 5 lines. Roscoe's nowhere to be found because Roscoe has no owner. This is the difference between join and left join. Left join will include all of the things in the left table and their connections. Whatever it doesn't have, it will be filled with null, which means the absence of in SQL. SQL's kind of interesting. We could have true values, false values, and null values. So it's a 3-sided, I think, ternary logic, as in it can be those 3 things, but null is the unknown or absence of. And we have left join. These are the most common joins, okay? If asked any kind of question in an interview, there's a decent chance it will involve these. If it does, you should get it immediately. If it doesn't, it's a slightly harder question, perhaps. But these should always be on the front of your mind. Now, that being said, we've also heard of right joins, probably. So, a right join is the mirror image of the left join. So it would be everything from the right table and whatever they connect. So it's the same thing, but for the right side. Because of that, you might as well just make it a left join and order your tables in that way. Left join is like the standard. It's like a lot more popular than right join. There's nothing wrong with right join. What's going to happen if I throw in the right join? Who can tell me? If instead of doing left, I do right, what are we going to get? Karen?
You can have Roscoe with no owner.
I'm going to get Roscoe.
Yeah, you can get Roscoe right without owner information.
With the same information, but with Roscoe. What about Celine? Yeah, Giovanni.
It's gonna take us
And take us to the
And take out Celine. Right. So if I do the right side, we're going to get Roscoe, a cat I used to live with, and no Celine. Any questions on that? That's just this difference. Most important is left join and join. Brandon.
So the left tables would be the table you have on the left side of the arm.
The left table is the from, I believe. Now it says from users. That means users is on the left. And then, because that's your base table, that everything's from, and then you're from, and then you're joining, which would go on to the right, the same direction as read.
Right. You're first reading from users, and then you're reading pets. So users will be left because right? Reading left.
Yeah. Right, users appears first. It would go there first. Good question. Another join you've probably heard or read about. Full. Who knows what this might do? Marvin? Marvin says it's going to be everything, the left side and the right side. Like the full table. Right? It's pretty well named. I agree, right? So if we do the full join, we get Roscoe and we get Celine. That exists. That's not something you usually have to do. Really. I mean, maybe you'll come up across. I'm not saying you'll never do it, don't know it. Be aware that it exists. Be aware you're going to do join and left join a lot more. Okay? All right, so that's 2/3 of the lecture. The next section that I want to talk about is the warm-up, which will lead us to the next type of joining I want to do. Yeah, Ashia.
Is there a way to put in the values without having to count them? Say if you have a large number of values and you didn't want to
Okay.
count.
So the question is there a way for us to put things in when we're seeding our database without knowing the right ID, right? Yeah, there are ways. Some of the ways would be to go out and then make a query to select something where that name is something, and then get the ID, and then pass that in. So it's a little bit of a pain. It was easier with Rails. There might be some other good ways to do it. I wouldn't worry too much about that, though, for now. It's a good question, though. Okay, so let's go ahead and make another file here. I'm still going to just keep working in Intro to SQL tables, because it's just another table. So I'll just touch, and we can call this company.sql. And let's go ahead and open that up. Okay, so let's build out this warm-up. How do we do on the warm-up? Can I get a yes, no, maybe so? Okay. What were the hardest? What were the biggest hurdles of the warm-up? Deja, what'd you say?
The manager ID.
The manager ID? Okay. Is that what a lot of us felt was the biggest hurdle? Is the manager ID? Yeah. Anything else? Okay. Okay, so let's start this. So what's the first thing I'm writing? Help me out. Yeah, Rafi.
Drop database exists.
Drop database. If exists. Yeah.
Oh, I named it database pursuit quarters.
Okay. I'm just gonna call it company,
Okay.
but that's fine. What's this line do? What's it for?
Basically, if that database is running, it'll skip it.
Okay. Yeah, it will go ahead and drop it. Drop means delete. Okay. So if we drop something, we're deleting something. Okay. Next line. Who wants to help me with that? Yeah, Will.
Create database.
Create database. Company. Great. What's next? You see, huh? Okay, and what's this line do? Sorry, I couldn't hear you. Yes, this is connecting to our database. So when we've created the database, this connects it, and now we'll be able to write SQL to update, change it, and all of that. Great. Let's just real quickly make sure that I don't have any bugs in what I've written yet. So I'm just going to run this file real quick. PSQL-F company.sql. Okay, everything. Nothing, no errors got thrown, so I'm going to keep going. I must have decent syntax so far. What's the next thing? Sin? What are we doing next?
You're gonna put drop table if it exists.
Cool.
You're gonna recommend the table for employees.
Okay, if exists employees. Nice. Right, and this table is this is just dropping or getting rid of the table so that we can completely remake it from scratch if it already exists. Okay. What's our next line? Who wants to tell me the next line? Yeah, Brutus.
Create table employees.
Create table employees.
And then we open parentheses. We put
And we're going to throw in that semicolon, right? I like it.
then we put you guys for ID, a name, and a manager ID.
Okay, so let's start with ID.
It'll be serial primary key.
Serial primary key. Okay, so this means, what does this mean? Farrah. Great, so this, Farrah says it's going to generate the ID for us automatically when we create an entry, and then this will be the primary key of the table. Right? All tables should have this primary key. Okay? Next thing we said, let's just build on the minimum, by the way. Yeah, Siham? Name is text. Not null? Okay, I like that, right? Let's make it, we'll add a restraint to our table to make sure that we can't create empty employees. No John Doe. Okay, Marvin? So we're going to say manager ID int. Okay. Interesting. Okay, so there's something. So I think a lot of us have something like this. What is this manager ID? Rafi?
I think it's supposed to connect the manager to the specific employer. So like who the manager is this employer, who their manager is.
So whose manager? Which employee has this as their manager? Okay, yeah, fair.
Call it the foreign key.
This is a foreign key, right? I agree, right? This is a foreign key, and which table is it referencing?
The manager.
So we are only going to have one table. I like that guess, though. Ashia?
I think it's gonna reference its own table.
So it's going to we've got a foreign key that's going to reference its own table.
Yeah.
Okay, tell me more about that.
You do int references employees at ID.
Okay, I want to know more about why. References, you say employee ID, yeah?
Because you can have in your employees, you'll have your manager in there. So you want to take that manager ID and use that to connect to the manager's ID.
Okay. So she is saying, right, everybody's working for the same company, right? So they're all employees of this company. Just so happens that some of them will be managing some of them. And so they should all still be on this employees table. I'm into that. Yeah, Will?
No, that's exactly what I see what you're saying. Like, managers are also employees.
Managers are also employees. Yeah, I agree with that. Let's also just set a little rule for what we want to happen when that manager leaves. All right. So let's just do an on delete. What makes sense?
Set null. Set null.
So she has to set null. Do we agree with set null?
Cascade deleted.
So cascade would keep deleting. Yeah. So that would mean I definitely wouldn't have a job here today because right now Arthur is my 5th manager that I've had. Yeah, Rafid?
I was gonna ask, is there a way how if a manager ID gets deleted, it automatically puts it to a new manager ID?
Well, I think what we'll want is to set null, and then when if we had a new manager, we would then have to update that aspect of the table. We wouldn't want it to randomly do that, because otherwise, just some random. If my boss left, then randomly someone else was my boss. Wouldn't necessarily be too far off from what has happened in the past, but it might not be the best way for things to go. Any questions on, not on what I said, but on this? Yeah, Farah.
On the delete cascade, will that delete any reference to like other tables? Like if it's like the primary key ID is also like the foreign keys or something else, will it delete all the information associated with that ID?
Okay, great question. It would depend on, the question is about what will happen with, it's essentially what is on the lead cascade and how does that affect other tables. So only tables that have it say, hey, I'm the foreign key, I want it to be deleted on the cascade, only those entries at those tables would be deleted. So hypothetically, I could have a users table, I could have a posts table where a post has a user ID. I could have a comments table where it has a user ID and a post ID. Right? And different things could happen. So if I delete my user, this post will delete if I've set on cascade, otherwise it will set to null. If I set this and it deletes, well then this better. Then if this was on cascade, then this would also delete. If this was set null, then it would remain. So it's going to change what that foreign key is. It's either going to say delete me completely or just set that foreign key to null. All right. Cool. So we've got our employees. Let's just go ahead and run this again real quick to make sure there's no egregious errors. Looks good. Oh, I didn't save. That's why I never created a table. Okay, that looks good. So let's go ahead and add some seed data into this. Yeah, Sin?
Is there any way that you can set the default already?
Well, that is me setting the default. This is me setting the default to turn it into null. Or if I had done cascade, that's setting the default to delete itself. This,
You know, I could put like a different manager's name there instead of null, right?
well, so you would delete it and it would be set to null, and then you would have to go ahead and update that employee and give them a new manager, and that's okay. But that would probably be done from a different route or API call. That's a good question. Okay, so let's go ahead and add. How do I add something? I don't remember. Brandon?
Insert into
Okay. Okay. Nice. Cool. I don't remember at all what happens next. Could somebody help me? Yeah. Marvin? Value? Oh, yeah, right. Values. Perfect. Okay, so let's do it like how Pursuit's currently set up, I guess. A bit. So let's say let's pretend that Jess was the CEO. Okay, let's pretend the company stopped at Jess. The company actually stops at Juke, right? Because Juke doesn't have a boss. But let's pretend that Jess is the CEO. I don't know if you've met Jess. She's the one who just had a baby. She was pregnant for a while and then was gone for a while because of the baby. Yeah. Okay. So Jess will say she doesn't have a manager, so I'm just gonna write null. Okay. Jess manages a few people, but one of the people Jess manages, we can say, is Arthur. And so Jess's ID is going to be 1, and so Arthur's manager ID is going to be what? Because she's managing him. And her ID is 1. Okay? So let's do the next one. Okay, so Arthur is managing at the moment all of the instructors. Okay? So I will put myself as Corey, and my manager is currently number 2. Okay, let's list another instructor. So I'll say Alejo, short for Alejandro. You've met him, tall guy. Well, I think I'm actually taller than him. Anyway, his boss will also be Arthur. Okay, what? Right, so his number is also going to say 2. All right, and I think that's enough for purposes of what I want to do. Okay, so let's save that and let's go ahead and run this. And we've inserted 4 entries, and now let's go actually look at this database that we built. So I'm going to go to here. You can do yours in P-SQL. I'm doing mine just because I want to be able to change the font and stuff. I'm going to call it company. I'm opening it. And I get this employees. Great. So Jess has no manager, so it's just a null there. We've got Arthur, who's managed by Jess, and Corey and Alejo, who are managed by Arthur. Any questions on this table? So, let's pretend that I want to be able to see the manager's name on this table, right? So I want to see like the employee's name as well as their manager's name. Okay? With the person next to it, let's take a couple minutes and see if we can figure out which kind of SQL query we'll need to see the manager's name next to the employee's name.
You want to see the manager's name?
I would like to see the manager's name as well. I would like to see another row
Also, you want to see
where it has the manager's name.
Okay.
manager's name.
So you'll see Corey, Arthur, Jess.
You can start off. Well, we usually do that when we want to see everything.
apostrophes, colons, semicolons, and then we send it.
Oh, okay. Alright. So we're selecting the name and
That's what I'm saying.
we have to get really the name of the person and the name Yes. You can join them, that's what I'm saying. Join it, try it.
Well, what am I doing? I'm gonna say join employees. That don't make sense. It's not like you can't join a table to its own table.
Yes, you can.
But okay, then how can he just shut my phone down?
I'm not really far with it. You definitely can do it. Yeah.
It says it's specified more than once.
Two people are talking at the same time.
I'm pretty
She was first. What?
It says it's specified more than once.
What do you mean?
Like when I do the join,
Yeah.
it said it's employees is specified more than once.
You can't do it without the name.
Oh.
There's some bullshit.
So, alright, so we're just gonna keep this.
Just shot my thought down.
No, it's good. It's just, I can't see this.
No, not you, Corey.
Oh, yeah.
What did I do?
No, you shot my thought down.
What
Because
the?
I was like, oh no, you can't do that.
Oh, join the cell? Yeah, I didn't shoot it down. I opened up an idea that you were shooting down.
That is true. We have to create. So
All right.
we have to
Clap your
create
hands once if you can hear my voice. Clap your hands twice if you can hear my voice. How'd this one go?
Oh.
Yes? No?
No.
Maybe? Yes, I'm seeing a lot of no's. Did we all get to self-join on SQL Zoo?
Oh, no.
Probably want to go back and do it. Okay, so this is a self-join. Okay? A self-join is not like these in the sense that it has like its own little word self in there. Self-join just means that this is a table that is joined to itself. So how do we do that? Let's find out. Let's start with a SQL query. So I'm going to say, let's start with just select star. Right? Just start big, and we'll get smaller. Select star from employees. We only have one table, right? So So it must be employees. And then what? What do we need to do?
Self-join.
So self-join is just a join. So we have two join choices essentially here. We have a join and a left join. We can see the difference. Let's just start with join. And what do I want to join?
Employees.
Employees. Okay, so let's say I join employees. And what do I want to join those on? Hang on, I heard a couple whispers and didn't quite hear it. What do I want to join them on? What can help me? Ashia?
On employees.id.
Okay, so we're saying employees.id equal to
employees.manager.id, manager_ID.
employees.manager ID. Do we think this will work?
No.
Yeah. So the people who said no, tell me why.
I tried it.
Because you tried it and it didn't work. Right? Danny?
That's the answer.
Okay, you tried it and it didn't work. Right? That doesn't spoil it. You sin?
It won't work.
What? Because what? Because I misspelled something. What did I misspell, son? I think manager is spelled correctly. Yeah. Psych! Yeah. Marvin, what's up? Well, we are saying what we want to join things on. It's tough, right? It's hard. This is a tough one, right? Let's see what happens. So we run the current, and we get an error. That error says table name employee specified more than once. What do we think that means?
We have to rename it.
Yeah, but what do we think the table this error means?
Where it's from.
Yeah, right. It means exactly what it says, right? It's saying we have a table called employees, and we're trying to join a table called employees, and so it doesn't know. Saying employees is joining itself, and it's almost there, but it's not quite. So we have to name the table. So instead of calling this table employees, I'll just call it as managers. I should spell that one. Sin. You got me. Right, I'm going to call this one managers. Technically, I don't need this as. This as is optional.
Oh, really?
Yeah. So a lot of examples you'll see online won't have the as. I'm putting the as just for slightly more added clarity because it's our first time seeing it. In reality, I might just ditch it. Okay, so we say employees as managers. So now we have a table that we can call employees and a table that we can call managers. So what do we want to join now? Where do we want to join them on?
ID. Manager ID. Employees ID.
Okay, so almost. Let's think about it. Where do we want to join? What column of the employees table do we want to join? We want to join on those foreign keys, right? Foreign key and primary key. So the employee table has what foreign key?
Manager ID.
Has the manager ID, right? So we're going to say employee and manager ID equal to. Now we don't have. We need to join the other table, right? So we want to join the managers table. But where do we want to join the managers table? No, we don't. There's no place where the ID is going to match up to the name. It's a good guess. Kelvin?
Add ID.
Add ID, right? Because the manager will have an ID. And that should line up to our employee's manager ID. So we'll say managers.id. And let's run it. Oops. Okay. So we get something kind of interesting here, right? We have Arthur and Jess. And then we have Corey and Arthur and Alejo and Arthur. So that is what we wanted, right?
No,
Why not?
because you specifically said you want the manager and like in order.
No, I wanted the employee and the manager.
Oh.
But it's okay if it's the other. If we wanted it to be the other order, we just have to change from star and just order it differently, which would be okay. But we're getting all the information we have requested. What if I wanted to include Jess on here? What would I change? Fowler?
You could just do left join, so it'll give you all of the employees.
Okay.
Or right, whatever you feel, 'cause that's gonna give you the same whatever is missing from either table.
Okay, so Fowler says if I say a left join here, then we'll get all of the employees, regardless of whether or not they have managers. Will this work?
Yeah.
Raise your hand if you think it will work. Raise your hand if you think it won't work. You almost raised that. Okay, do you want to defend why you say it won't work?
Maybe a full join would probably be more safe if we're trying to
Tell me more about why. What do you mean by more safe?
because if this table is only giving those with managers and we want to give them without managers too, then I guess we can just use full join to get all of these to the table.
Maybe. I'm not so sure. That could be an alternative. But I do think left join is going to be what we're really looking for in this one. And I hope I'm right. Yes. So, because we don't really want all of this information. And I don't know when the manager wouldn't have an employee if they are a manager. That to me feels a little bit more confusing. If we choose the left join, we get all of the things, all of the employees from that left table there, and then we also get where the right table connects. All right, so this is a self join. So to recap, we did join. This is where the rows, both tables have IDs in common. An ID matches a foreign key, and only those rows will be what's left over. We talked about left join, which will have everything in the left table, and then just whatever else matches from the right. And then we talked about self joins, which is this idea of joining yourself with where you have a column in your table that references your table. I think a common problem with those is like, well, this one is pretty classic, and then there's also like train stations and trains that leave the station because they share a station ID things. I don't really remember. I think it's in Sequel Zoo though. Any questions on anything that we covered today? Yeah, Jay.
When you said as is used for clarity, if you don't use as, is it just a space?
Yep, good question. So if I remove the as, everything works just fine. I just say space and then the name of the table that I want. As is purely being used for clarity. Great. Follow-up. Anything else? Henry, is that a question or is that just a thinking? Cool. Click and click on. Brandon.
You said that this is an example of the self.
This is an example of a self join. That's right. So it's not a new type of join. It's just a table that's joining with itself. And it's joining in usually one of these two ways. Great question. Anything else? All right. That's everything that I had.